To class. In session 5, we're going to focus on how to get the ball rolling. Kind of like the chicken and the egg story. If everybody's running BGP and they're all sharing routes, well, how exactly do you take a route that you own, that you've been assigned to? How do you actually get that into BGP? That's going to be our focus point for this lesson. And there's several different options. So in our journey, where are we? We are specifically still in BGP fundamentals and network statements and injected routes. So let me bring you over to my live demo. I'm going to walk you through most of this and reinforce it through a live interface. So let's go over to demonstration. Alrighty, that looks very, very good. Okay, so as far as getting networks in, let's take a look at our plan of action, what we need to inject. We have an internal BGP neighborship between R5 and R6, and let me use green for that, and there we go. And we have an external neighborship between R6 and R8, and let's just take a look at some networks that we might want to add. First of all, BGP, for the most part, a router can't inject a route that it doesn't own. Sort of like that Top Gun saying, son, your ego is writing checks your body can't cash. So routers are not allowed to actually say, hey, here's a new network to put into BGP unless it's somewhere in the routing infrastructure of that router already. So R6 has a couple networks we could play with. R6 has the 6.6.6.0 network, which is a loopback, which is a route local to that. It's also got a 10 network. 10.56 specifically, the subnet between R5 and R6/24, and it's also got a 24 network. So what I want to do is walk you through setting up and adding some of those routes, injecting them into BGP as we can watch the process go along. So let's go over to R6, and let's first of all play with the 10 network. So over at R6, as I bring this up, that doesn't look like R6. That looks like R6. All right. So our BGP router ID is set back to the way it was. That's all good. So let's do a show IP BGP, and that'll show us our BGP table. And any routes that R6 sources normally are going to have the next hop of 0000, meaning that's me. Then when I advertise that to neighbors, that advertised route will show me as the next hop for that neighbor, for the benefit of that neighbor. So let's do a show IP interface brief. We'll exclude the unassigned interfaces. And let's take a look at advertising this 10 network. Let's do 1056. That network right there we're going to bring in. Now that's if we look at the interface, we do a show run interface for the 65 interface, it would show us literally how long it is. Now when we add, by default, auto summary is off. Just like in EAGRP, it's off. Well, I take it back. Just like we normally disable auto summary in EAGRP and RIP, with BGP auto summary is off, which means that if I want to add this network to the BGP process, I need to explicitly specify that network with the correct mask. So if I do a config T and router BGP, we'll go into AS3 because that's our autonomous system. The way I advertise that network is I simply do network, and I put that network in, I put the keyword of mask, and then I put the appropriate mask. All that says is this: hey, I'd like to introduce this network into BGP. It's not there yet. So if we look at the BGP table up here, you'll notice that there's no 10.56 network in the BGP table. We'd like to introduce it. Because auto summary is off, we have to put the explicit classless addressing in for it. So 1056.06 should take it, and it says Keith, your mask is all whacked out, and that's because I put a 6. It's like BGP saying, I don't think you meant to do that. Yeah, the network is actually 1056.0 with a 3-octet mask because I had some bits on in the non-network portion. It said think again. So I'll put the right network statement in, and then if we do a do show IP BGP, that should show up in the BGP table. So now it's here, and now we're sourcing that route. So if we go down and look at it at R5's perspective, R5 should see it with the next hop of R6's address, and R8 should see it with the next hop of R6's address. Let's go take a look. So we'll go down to R5, just to make sure we're all on the same page here. So R5 is right there in the middle. We have an iBGP neighborship that we set up in our last session to him. So on R5, if we do a show IPBGP, there is our network statement. Now it's all looking pretty interesting. Because this was learned via internal BGP, from R6, the iBGP session, we actually send the attribute of local preference to internal neighbors. We don't send the preference to external neighbors. So the local preference was set as 100 because that's the default. The metric or med was set to 0 because we didn't change it. The weight is set to 0, and also because that's a local thing to R5. And take a look at the AS path. The AS path is empty. If we were to look at this with a protocol analyzer, it would say AS path attribute, no paths. That's because it's sourced from within Autonomous System 3 and we're sending it to an internal BGP neighbor. If we send this update out to R8, R6 will prepend the Autonomous System of 3 to it and send it on its way. One of the benefits of the AS path is to help eliminate loops. So if we go to our diagram, if R6 sends the 10 network to R8 and it appends right here, it says the AS path is 3. Let me get black for that. 3. Then R8 sees, okay, the AS path is 3. And then if AS89 sends that down here to R2, it will add to that the AS path of 89 space and the one it got it from 3. And as R2, another external neighborship, advertises that up to R1, he'll add his AS on it, so it'll look like 22 space 89 space 3. And then as R1 advertises it this way, basically he's going to add on to it. He's going to say 11, 22, 89, 3. And when R3 gets it, because his own AS is 3, he's going to freak and say, wait, we sourced that route. We don't want to learn it through some other connection. And it will actually not accept a route with its own autonomous system in the path. That's one of the major benefits of this AS path attribute called AS path, our path attribute called AS path, is that it's helping to do loop prevention as well. So external neighbors, when we send a BGP update, we are going to add on to that AS path our own autonomous system as it goes out to external neighbors. All right, let's go back to R5. So there's the route. If you'll notice, the next hop on this route is 56006, which is okay. I mean, that's R6. But take a look over on the far left. See how it says R? R, what does that mean? Now that's in the origin code. So an R over here simply means we have a rib failure. Now that sounds bad. It's like, oh, broken rib, what's that all about? The routing information base simply says take the best route and use it. Well, this is the BGP best route. We can tell that because of this symbol right here. But the R says we lost out from the global routing table. Somebody else beat us out. If we do a show IP BGP, was it rib failure? It'll simply say, oh yeah, for this network 1056 with the next hop of 5606, there was a higher administrative distance. Somebody else already advertising that. So this route didn't make it into the global routing table. That's all that says. So who did win? If we do a show IP route and we look just for that one network, which is the 1056 network, and it says I'm directly connected. That means I have an AD of 0. AD of 0 is slightly lower than an internal BGP neighborship AD of 200. So for that reason, this route's in the routing table via a connected route as opposed to BGP, and that's what the rib failure means. All right, where are we going with this? Oh yeah, we're adding networks. So let's go over to R8. R8 is our good buddy on the top right-hand side. I just want to verify that R6 advertised it to R8. And you'll notice that on R8, it's going to have the AS number that this came from. That's because R6, when it sends the update over to its good friend R8, because it's an external BGP neighborship, it's going to prepend a 3 in the AS path. So we should see on R8 an AS path of 3 for that specific update. It'd be great if that works out. So let's go to R8, do a show IP BGP summary just to make sure we have the neighborship. Look at that. This is R8 saying I got one prefix. I learned one prefix from my neighbor at 68.6. Fair enough. So we'll do a show IP BGP, and there it is. If you'll notice the AS number, the AS path that it came through is 3. Also, notice how it says I? This I on the far right represents how it actually got into BGP. So that deals with this origin code right here. So the origin code of I says it was learned via IGP, which means back on R6, we did a network statement. Because that route was in our routing table, we were able to go ahead and put it into the BGP. That's what it means when it says it was learned via IGP. It was a network statement. It wasn't really, we weren't redistributing IGP into BGP. We used a network statement because the global routing table had it via an IGP. It was allowed in. That's what it means. So there's the detail for that. And let's go tweak it a little bit. Let's go back to R6. Let's have some fun. I'm going to take out that network statement. I'm going to do a no. And let's do a do show IP BGP, and now that network is gone. So it was there, we took it out, and now it's no longer there. Happy days. How else could we add this? Let's do this. Let's do a do show run section router BGP. I just want to show you what the BGP configuration is by default. All we've configured so far on this router for BGP is what we've done together. So I've got my BGP router ID. I've got this BGP log neighbor changes. That was a freebie. I didn't have to put that in at all. That's why those little messages come up when neighbors go up and down. I specified that R5 was a internal BGP neighbor. I specified that R8 was an external BGP neighbor. I specified that on R5 I want to change the next hop attribute to be myself so that he has reachability to that next hop and will possibly use the BGP routes. But these two are free. No auto summary, freebie. No auto summary says, hey, I'm dealing with classless. That's all I'm doing. So if you have a network, make sure you put in the exact mask and I'll be happy. If we turn that feature off, we can add network statements, and as long as we have one of the more detailed component routes in our routing table, it will advertise that summary route for us. I'll demonstrate that here in a moment. The other thing that's legacy, that's not on anymore, it used to be 10 years ago, is no sync. Synchronization, if it was on, would say this: I am not going to accept a BGP or use a BGP route unless it's also present inside of my IGP, like OSPF, ISIS, etc. That seems kind of lame, and in today's modern networks it is lame, because we're not going to redistribute all the routes from BGP into our IGP, especially if we have the entire internet. It's not reasonable to do. So synchronization is off by default. If we're a transit area, that does mean, however, that every single router inside our network needs to be running BGP, at least for straight up IPv4. If we're doing VPN services with MPLS, that's a different story. But no sync is off by default as highlighted, and auto summary is off by default. So let's do this. Let's add the network 10 again. If I just press enter, it defaults to a classful mask. So if I had the 10 network locally on this router, it would pop in to the BGP. So I don't, however, have any exactly 10 networks in the routing table. I've got subnets of 10, but not the 10 itself. So if we do a do show IP BGP, you notice the 10 networks, I've got several. Do show IP interface brief, excluding the unassigned. Okay, I'm not going to exclude the unassigned, but I've got three 10 networks. I've got the 36 subnet, the 56, and the 67. I did this statement, network 10, and if I do a do show IP BGP, none of them made it in. And that's because it's acting classless. It's saying, you know what, auto summary isn't on, and you got to put in exact routes that are in your routing table if you want them to be introduced into BGP. So we could go ahead and turn on auto summary. Auto summary says, okay, I'm going to summarize the classful boundaries. So you put in a network statement like this one right here, which I already put in, and what I'll do is if you have a subnet of that major class A network, the 10, I will add a 10 network advertisement to the world. Now hopefully, if I'm advertising the 10 network, hopefully I own everything in the 10 space. Otherwise, this is a tragic error, because then I'm going to be building a control plane that says 10, send them this way. And if there's other networks that have 10s that are advertising those as well, the same problem shows up. We could advertise another network. Let's pick, how about this one? That's a 24-bit 23 network. 23.0.0.0/24. I can say network 23, and because I have auto summary on and I have a subnet of that network in my routing table, it's going to go ahead and add that. So if I do a do show IP BGP now, you'll notice I've got a 10 network that's being advertised, and I've got a 23 network that is being advertised. If I turned off auto summary, it's back to the basics of, okay, you have to have exact matches. So I'm going to turn that off. The no auto summary, which is back to the default behavior. And if we do a do show IP BGP, you'll notice those two routes are gone because I don't have exact matches. If I want to make exact matches, it'll go ahead and put them in. So let's add the 10. Let's add the 23 network. Actually, let me take those out. Up a little bit here. So take out those two summaries, and let's put in a full route for the loopback. So we've got a loopback interface. Do show IP interface brief, exclude unassigned, and let's put this loopback, which happens to be our router ID. However, it's also a network. It's a 24-bit network we're connected to. So with auto summary off, we'll do network 6.6.6.0, the keyword mask, and 3 octets to indicate the mask. And now if we do a do show IP BGP, that network is now in BGP. And it's now being advertised to any peers that we have, internal and external peers. Okay, so that's auto summary in a nutshell, what it does, how it works. Let's take a look at what R8 thinks of that route. So we'll go to R8 for a moment, do a show IP BGP. There is our loopback that we just added. If you'll notice on the far right hand side, may I direct your attention to the far right hand side of the screen. The AS path is 3 because when we got it sent to R8, we prepended this AS path that we're in to this neighbor, so you can keep track of that. And it's also an internal, it's also an origin code of IGP. So that I on the far right, it also represents the origin code that it came from IGP. I'd like to change that for a little bit, and I'd like to go back to R6. I'd like to take that same concept of bringing routes in, but I want to do it with redistribution instead of doing it with a network statement to show you the difference. So let's create a static route. I could do redistribute connected, and that will bring them in as well, but the different origin code. Let's do a static route. Let's do IP route, and let's create a route for a network that we'll just make one up. So IP route for 88.88.88.0, 255.255.255.0, and let's say the next hop is, let's pick a next hop together. Let's say the next hop for that static route is 192.168.68.8, this guy right there. So we're creating a static route that says R8 is the next hop for it. And then we'll redistribute that into BGP. So we'll say 192.168.68.8. Okay, static route. And we have reachability to the next hop because we have a BGP session there already. We know we have connectivity. Now I can redistribute that. Router BGP3, I can say redistribute static and press enter. If I put a metric on it, that would equate to the med value, which we can do that in a second. But now if we do show IP BGP, take a look at this. Here's our static route. We redistributed into BGP, but take a look at the origin code on the far right, the question mark, where it says incomplete. That simply means it was redistributed into BGP. They should have put an R there, but I guess R was already taken for a rib failure. But if you do a redistribution into BGP, it's going to be showing up as a question mark. If you use a network statement, it's going to show up as a I for it came from a IGP. And those are the two of the differences. So if we go over to R5, here's another little piece of magic here. R5 is our internal BGP neighbor. If we do a show IP BGP, there's our static route. The next hop of 10.56.0.6, that is there because we told R6 every time you send an update to R5, put your own next hop on it. But if we go to R8, let's go to R8 and do a show IP BGP and take a look at this route. Because in our, there we go, because it's an external BGP neighborship, come on, highlight. I'm using the trackpad and it doesn't want to highlight. So there's our static route, and there's the next hop attribute, and again the question mark at the far right. So the difference between a network statement and a redistribution into BGP, why do we even care? That's a good question. Glad you asked. The reason we care is that there's a decision-making process that we are going to master in this course, which lets BGP determine which ones are the best of the best. And as it goes through this decision process, one of the questions is the origin code. Is it I or is it a question mark? And if it's an I, it would beat out the question mark if it came to that point in the decision-making process. So we can actually manipulate that as well. We can have a redistributed route. We can actually change that attribute of origin and through a route map as we send the updates across. But it's just another one of the attributes that we can mess with or play with working with our BGP. So let me see what else I had on my notes that I wanted to cover with you. Let's do it again on R6. Let's just change the metric so I can show that to you. So we did a redistribute static. If we said metric of 333, and we did a do clear IP BGP soft, that's basically going to say to everybody, hey, inbound and outbound, need all your updates. Here's all my updates. So what happens with BGP is this. If you and I are neighbors, and I've sent you a whole bunch of updates, you know what those attributes are. Med, local preference, etc. And you're just going to think that's the case. If I do a soft reset or a soft update, I'm going to send you those again with the new information. As a result, when you get it again with the new information, you can update your BGP tables. See, by default, you might think, hey, I'm fine. There's no reason to send me updates unless there's changes to them. And so doing a soft reset forces a new update, which would force the neighbor to reread those attributes and listen to them. So if we go to R5 and we do a show IP BGP, you'll notice that for this one route right here, the metric is now changed to 333, which is the MED, the multi-exit discriminator, which we'll be playing all about as we take a look at lesson 17, which is a few sessions off. And let me take a look. So we've taken a look at setting up the origin, or how the origin flag has changed, redistribution, redistribution from static, and how the neighbors all see it. Two other little pieces that I'd like to touch on, and then we'll be done with this lesson, is the concept of setting up additional routes and putting them into BGP. And let me just bring you up to that slide real quick. Oh, and I also want to do a default route too. Let's do that right now. If I wanted to send a default route to a neighbor, it's so interesting. In BGP, you don't even have to own a default route to share it with others. So we could, if we wanted to, we could have our R8 tell R6, hey, if you need to forward traffic anywhere, I'm it. I'm your guy. And we could source a default route over to R6, who would then advertise that down to R5 and so on and so forth. So Let me show you exactly how to do that. Let's go on R8. Right screen up here. So on R6, let's just verify that if we do a show IP BGP, there's no default route that we've learned from anybody on R6. So we'll hop over to R8, and on R8 we'll do a config T and router BGP Autonomous System 89. Autonomous System 89, and we're going to say neighbor of 192.168.68.6. We want to go ahead and say default information originate. And when we do that, poof, we are now advertising a default route to that neighbor. Now we don't have one. Don't get me wrong here. Do show IP BGP. This isn't for ourselves. We don't have a default route, but we're actually sending one over to R6. So R6, if we look over him and do a show IP BGP, you'll notice that now, right here, we have a default route. Next hop is R8's IP address. And if we look at R5, that same default route should be propagated down to R5, but because of the next hop self, the next hop should be changed. So here's that same default network advertised from R6 to R5, and now R5, holy cow. If he doesn't know how to reach one of the networks in his global, let's see if it made it to the routing table. Show IP route. There's a lot of routes there. There we go. So here's our default route learned via BGP. So if this router doesn't know how to forward to any specific subnet in its routing table, the 10.56.0.6 is going to be the next hop, which is R6. R6 doesn't know how to reach that network, he's going to forward it to R8. If R8 gets it, doesn't know how to forward it, it's going to drop it. So although we can do this in this scenario, unless R8 really was the key pin to the rest of the world, that probably wouldn't be a good design, unless indeed it was our single only way out of AS3 and R8 was our guy, then that might be a scenario. But if we had other routers, we're multi-homed, that might not be the best decision to accept a default route from one and not from anyone else. All right, a couple other things I wanted to share with you. Aggregation. If we wanted to summarize routes, we can do that as well. So if we want to, summarizing is so simple. It's taking a bunch of more detailed networks, which I call component networks, sub-networks if you will, and then advertising them as one larger block of IP addresses. Why would you do that? Well, if we didn't do that on the internet, we would have more than 300,000 plus routes. So we're basically taking groups like networks in Asia, networks in North America, and so forth, and we can summarize those so we don't have to advertise the more detailed routes. They're called aggregates. So we can do atomic aggregates. We're going to cover that in a separate section. But the key is that we can take a whole bunch of routes, summarize them, so that the neighbors don't have to learn 48 different routes from us. They can have one summary. It's also important to know that we shouldn't summarize for networks we don't own. So it's very important to get that right. As an example, let's take this AS, busy AS, isn't it? Let's go ahead and open up a new drawing. Open, don't save that, and we'll open up this. Let's say we had a whole bunch of subnets in the 23 address space, 23.x.something.something. Slash, let's say 29. And we wanted to summarize those to 23.x.x.x slash 26. So we could take, basically, let's say we have 30 routes here. We could take those 30 routes in the 23 address space, summarize them to one summary route, and then advertise that summary out to good old AS89 and advertise that summary out to R1. And that way we're not advertising, we're keeping the number of routes down. So later in the course, as we get to some more complex multi-exit scenarios, we'll actually implement this. But at this stage, as far as getting routes into BGP, I wanted to make sure you're aware that that's an option. Now, if R6 does say that he's going to summarize the 23/29 network into a /26, R6 has to have at least one of those more specific subnets in its BGP table to do it. When it advertises that summary, it also has the option of sending the summary plus all the detailed routes, which seems a little to defeat the purpose. It could send the summary and some of the more detailed routes, and it could send the summary and none of the detailed routes. So we can actually control exactly what's being sent to our peers to manipulate how many routing updates and how many networks we're actually advertising out to the world. Again, the important thing for R6 would be not to over summarize. And what would happen if we did this? If R6 said, yeah, I can reach 23, the 23 network 8-bit, that would be way too much, especially if we only owned the /29 subnets. Summarizing it to a 23.0.0.0/8, we're obviously summarizing other people's networks as well, and we're not playing well with others. We also need to be aware of that in the real internet. We want to put controls in place so that people can't do things to us. For example, if we own a 23 network here, let's say it's a /29, it probably would be a good idea never to accept inbound updates from R1 or R8, or for that matter R2 if he's sending them, that are saying that they have reachability to our 23 network /29-bit mask, because they're claiming they can reach it, but they can't. So you want to make sure you do those type of protections as well. That's kind of common sense, but you just can't rely on everybody to, for example, otherwise, if we just trusted everybody, we would be sending RFC 1918 addresses, source addresses, out through the internet, which obviously those are non-routable on the public internet. So we filter those. We stop traffic that shouldn't be transiting our network. We stop traffic that advertisements, control plane traffic that shouldn't be entering our network, just to make sure everybody's playing by the same rules. So that is the aggregate. There's one other one I want to share with you, and that is the inject map. An inject map is another option we can use to do conditional advertising. It's one of the few that doesn't require a route to exist in our BGP table. So we could say if this network is reachable, or if this network exists, I want to go ahead and advertise network 23. Even if we don't have a 23 network in our routing table, the inject map will allow us to add it. So in summary, a little pun there with my aggregate. In summary, there's 4 basic ways to get routes into BGP. A network statement, which makes them show up as origin of IGP. We can redistribute them. We can redistribute from static into BGP, from routing protocols into BGP, from connected into BGP. Any way you redistribute, though, it's going to show up by default with a question mark as the origin code, meaning there wasn't a network statement on the original router. It probably was redistributed. Third, we can use aggregates. So with the aggregate routes, which we set up in BGP, as long as we have a more detailed route in the BGP table, we can advertise a summary. And then the fourth is a BGP inject map. With inject maps, you don't actually have to own the network, but you can conditionally advertise a network, and that's one of the few ways to get that done. So that's it as far as getting routes into BGP. And we'll demo the aggregate and the BGP as we get into the multi-home scenarios that are coming up. And I think that is everything that I wanted to cover in this lesson. Let me take a look at my notes. Oh, and one last piece. I take it back. One last piece. I mentioned this, but just wanted to reinforce it. Synchronization is off by default. If it were on, all your BGP routes, unless they had also been learned via an IGP, like OSPF or ISIS, your router wouldn't consider them as viable, and it wouldn't advertise them on to other neighbors. So that's old school. By default, synchronization is off, meaning you don't have to have 300,000 routes in your IGP in order for BGP to consider those valid routes. And again, for certification, it's important you're aware of that. In the real world, we're not using synchronization very much anymore in our current implementation of using BGP. So that's it. In our next section, we're going to take a look at loopback interfaces, how to use them inside of a single autonomous system for reliability and the drawbacks and problems that can come up by using a loopback as a peer point for an iBGP peer. Thanks everybody. I'll see you in the next section.